Hi everyone, in this video we're going to work through another example that I hope at least feels somewhat like review. Here I want to start with a quadratic in vertex form, or transformations form, I've seen it called in some books before. And we're going to figure out what we get for free, what we have to work for, and a couple of other things along the way. Okay, so very first thing, we want to find the y-intercept of the graph. And you want to be careful. This is where I say, if you want the really fundamental important idea, that would be that if you want to find the y-intercept, you're going to let x equal 0. People are tempted to confuse this with standard form and say, oh, well, it's just 4. And that's actually not true. If we let x equal 0, we get negative 3 times 2 squared plus 4. So we get negative 12 plus 4, which is negative 8. So definitely not the plus 4. So only if you're written in standard form, where the first term has an x squared, the second term has an x, and plugging in 0 gets rid of both of those, can you snag this number. Bottom line is, if you're unsure at all, plug 0 in for x and just crunch through the work. So y-intercept is not a freebie. 0, negative 8, nothing terrible, but we don't just get it for free by looking at the equation. We'll have to actually plug 0 in. The vertex of the graph, okay, maybe you could guess by the name of this thing, this was vertex form, and the vertex is what we get for free. The reason for that being, this is the form that you can see transformations from. So if I think about starting with a basic y equals x squared, I can see the negative 3 out in front will be a vertical flip, so flip over the x-axis, a vertical stretch by a factor of 3, a shift left 2, and a shift up 4. The key thing to realize is that basic y equals x squared shape. The vertex is at 0, 0, so the flips won't affect it. No flips will affect it. No stretches or compressions will affect it. Only shifts. So the left 2, up 4 tells you your vertex for free. Negative 2, 4. The one tricky thing is recognizing that there's a sign swap that happens. So if you have an x plus 2, this should be easier for us because we've done transformations. We know that's actually left 2, so the vertex will be a negative 2, 4. We're basically looking for what gives us a 0 in the parentheses, and then we'll end up with that 4. Okay, so let me grab my cheat sheet here about things you should be thinking of. We're working on vertex form. So again, this one's the easiest form to get the vertex from. And here's kind of my basic formatting. But again, if you're understanding your transformations, I would say you shouldn't have to memorize that. You should just recognize, oh, I can see transformations. If it was a minus h, that would be right h, and a plus k, assuming k is positive, would be up k. So the vertex will be at hk. So again, you should just be able to read the vertex off, being really careful about the fact that the sign in here will swap. If it's a plus 2, it's actually left. And here again, I put an extra note here because a lot of people make this mistake. The y-intercept is not k. That's the y-coordinate of your vertex. Every once in a while, the vertex is at the y-intercept, but that's not something that's true in general. So if you want to find a y-intercept, let x equal 0 and crunch through to see what you can get. Okay, x-intercepts of the graph. So again, the fundamental thing I want you to remember is that no matter what type of function you're working with, if you're looking for x-intercepts, you let y equal 0. So we're going to let 0 equal negative 3 times x plus 2 squared plus 4. You have some choices here. You could FOIL out the x plus 2, distribute in the negative 3, and then try to factor. I'm actually looking at this thinking it looks like it's really nicely set up to use the square root method, so I'm going to walk you through that. So you do have other choices, but the square root method is kind of a nice one that a lot of times people forget about. So if you want to use the square root method, it only works when you have the single x, which we do. So we're just going to get rid of everything that's over here with x. We want to get rid of the last thing that happens first. The last thing that happens is the plus 4. So we're going to subtract 4 from both sides. We then want to get rid of the negative 3. It's attached by multiplication, so we'll divide, which is going to leave us with a positive 4/3. Now we need to get rid of the square. To get rid of a square, we're going to square root both sides. We'll say plus or minus the square root of 4/3 is equal to x plus 2. I'm going to simplify that radical just a little bit. Right now, what I want to do, though, is just my last solve step. I'm going to go ahead and subtract 2. So I have plus or minus the square root of 4/3 minus 2 equals x. I don't require a lot of simplification with radicals. I would say here, I'm seeing the square root of a perfect square. I would always expect you to look for that. So it's important that you realize that you can split square roots over multiplication or division. They do not split up over addition, subtraction, but multiplication or division, you can split that up. And then on the top, the square root of 4 is 2, so we get 2 over root 3. I am completely fine with this. A lot of times textbooks will want you to rationalize the denominator. Really, at this point in time, there isn't a big motivation for rationalizing denominator. That was more about if you don't have a calculator, this is really hard to get a decimal approximation for. But it is a skill that you should have, knowing how to get rid of square roots. So just to point it out, we could multiply top and bottom by root 3. I kind of crunched myself. So we get a 2 root 3 on the top. On the bottom, we would get root 3 squared, which is just 3. So if you want to take that extra step, it is certainly not wrong. I have no problem with it. It isn't required, but you should recognize that these are the same solution. That's going to be important. And a lot of this comes up in trig. So just practicing some of that radical work is good. Okay, once again, remember, so I'm going to go back to my 2 over root 3. That looks a little simpler to me here. That if I ask you for x-intercepts, I am looking for points. So write them both as points. Okay, so again, I didn't ask for it here, but I'm going to do it just to remind you, since it is supposed to be review. We should be able to get a pretty decent sketch of this thing at this point. So if we're looking at y-intercept 0, -8, the vertex is at -2, 4. Oh. I'm just looking here. This didn't look quite right, and it's not. We need a -2 in here. -2. Sorry for that. Okay, and then intercepts a little bit away from -2 on each side. Okay, so let's go like this. I'm going to go, oh, and we need lots of room at the bottom. Okay, so we have a vertex at -2, 4. Y-intercept at 0, -8. And then our x-intercepts are just a little bit to the left and right of -2. And you can even check a decimal if you want on this. You could say, what is 2 over the square root of 3? Oops, square root of 3. What were we doing? -2. It's about -0.8. So this is 1 right around here. And then we could do the same thing. Second enter is really handy, by the way, if you just want to pull up the last thing. Also, depending on how new your calculator is, you might just be able to arrow up and hit enter and snag the last thing. Those are both handy. And then this is -4, just past 3. Okay, so the vertex, and it looks like we're going to open down from there. And there we go. Oh, a great one that I don't think I've mentioned yet. This -3, I did mention it in transformations, but a good one to point out is that in general, if you're looking at a quadratic, if the number that would end up in front of your x squared is negative, it's always going to open down. And if the number in front of your x squared is positive, it's going to open up. So there's a rough sketch of the graph of this thing. Let's see if we missed anything on the vertex form list. I don't think so. So it's really good to use square root method to solve when you're in this form, but it's not required. Okay, so last thing here, I find that a lot of people have gotten a little bit rusty on figuring out where two graphs cross. It may have been a little while. This is something you at least should have done before with finding out where two lines cross. If I want to know where the graph of this quadratic crosses the line y equals 3x plus 4, let's see, that's a line with a y-intercept of 4 and a slope of 3, so we'll go down 3 over 1. Not exactly sure where on this end, so here's a rough sketch of that line. I wouldn't rely on it too much to tell you where they cross, but a rough sketch. Okay, so I'm looking for two intersections, and I do expect them both to be to the left of the y-axis, but I wouldn't try and get much more than that from my very imperfect picture. If you want to find where two graphs intersect, you're looking for points where the x and the y coordinates are the same. So if the y coordinate of L of x is exactly the same as the y coordinate of g of x, We can show that algebraically by saying if these two y's are equal, we just set this equal to this. So if L of x is equal 3x plus 4 and L of x equals g of x, then we could just replace g of x with the 3x plus 4, or vice versa. So basically, you end up taking the two equations and setting them equal to each other. Okay. This is not looking so nice for the square root method because I have more than one x floating around. That's not going to work out for me. So this time I am forced to go ahead and FOIL and then distribute. That's the order that you'll want to use. You have to deal with exponents before you deal with multiplication. And technically, you would want to deal with what's in parentheses before you deal with exponents, but because we can't combine the x and the 2, we go for other algebra tricks, in this case FOIL, to get rid of them. So I have a 3x plus 4 is equal to negative 3 times x squared plus 4x plus 4. And then distribute the negative 3. Okay. At this point, I want to do a couple things, combine some like terms and set it equal to 0. So I'm actually noticing something. It's okay if you don't notice it right now, but I have a plus 4 on both sides. So I'm just going to mentally say, well, if I subtract 4 from both sides, then that is all gone. So the 4 is gone. Because this is a negative x squared, I'm going to go ahead and move everything to the left-hand side. So it's up to you. You have other options, but I like to end up with that positive x squared. So I'm going to add 3x squared. I'm going to add 12x, since I'm adding that to the 3x, I'm going to get 15x, and I'm going to add the 12. 4's are all gone. Now I can work on factoring. At this point, I would either divide out a 3 or factor out a 3. It doesn't matter which. So if we have 3 times x squared plus 5x plus 4, now we can do a little better. X plus 4. X plus 1. Okay, so 3 cannot possibly equal 0, so that factor doesn't give us any solutions, but x plus 4 can equal 0 if x is equal to negative 4. And x plus 1 can give us a 0 if x is equal to negative 1. So it looks like we are getting intersections when x equals negative 4, x equals negative 1. The wording on this one isn't super specific. It just says, when does it cross? So that is a decent answer. We could also do a little better than that. We could give actual coordinates of points, and it's fairly easy to do. We now have the two x coordinates that make our y values the same. If we want to know what the y value is, we can just plug it into either equation. So I would choose the top one. If we plug a negative 4 into L, we get negative 12 plus 4, which is negative 8. So they cross at negative 4, negative 8, so I wasn't too crooked. And if we plug in negative 1, we get 1. And if you want a really good check, you could also plug negative 4 and negative 1 into G. If you do not get negative 8 and 1, then there's something wrong. You should get the same answer from both equations. So that's not a bad way to check yourself. All right, I think that's all I've got for this one. Thanks for watching.